Hello everyone, welcome to my YouTube channel. My name is Vikas Mitra. So in today's video, we're going to see operations on a discrete time unit ramp function. So basically, this is one of the unit ramp function that r of n is equal to n for n is greater than equal to 0 and 0 for n is less than 0. So in this case, whatever the time is there, we are getting the same amplitude for that particular time. So n equal to 0, so we have a 0. So n equal to 1, we have a 1. N equal to 2, we have a 2. N equal to 3, we have a 3. N equal to 4, we have a 4. N equal to 5, we have a 5. So basically whatever the amplitude is there is equal to time. So this is the condition for the unit ramp function, because we have to satisfy each and every condition that we have defined. So first thing, this is a unit ramp function that already we have discussed. Now, if we want to apply some operations on a unit ramp functions, so how we can apply? So for example, the first operation, that is nothing but time reversal. So what is meant by the time reversal? So r of minus n. So whatever the signal is there, just we have to reverse that signal. We have to reverse that signal. So for example, this is r of minus n. So that signal will be r of minus n is equal to minus n for n greater than equal to, okay. So basically n for n is greater than, sorry, less than equal to 0, and 0 for n greater than 0. So just we have to reverse that signal. So whatever the amplitude for 0 is 0, whatever the amplitude for minus 1, that is for plus 1, again same, whatever the value of n, so is a minus 2, so is a 2. So the only the amplitude is same for each and every time period, but the time is reversed. But time is reversed. That's like this minus infinity. So in this case, we have taken time reversal operation. So in that case, only the time is reversed, but the amplitude becomes same, whatever the amplitude is there. So that is nothing but r of minus n equal to n is a time reverse. Now next operation that we are going to see, for example, if we want to write r of n plus 1, so how we can write n plus 1 equal to 0 to n equal to minus 1. So basically we have to shift that signal by the minus 1. So that signal will be start from a minus 1. So whatever the amplitude for 0, now that amplitude will be for minus 1. So minus 1 having a 0 amplitude, for 0 having a 1 amplitude, for 1 having the 2 amplitude, and for 2 having the 3 amplitude, for 4 3 having a 4 amplitude, 4 having a 5 amplitude. So basically that signal is only shifted by the minus 1, that's it, up to infinity, whatever the value. Next example, if I write r of n minus 1 is equal to n minus 1 equal to 0, so is n equal to 1. So basically that signal will start n minus 1 is nothing but that signal will be that signal will be start from from plus 1. So whatever the amplitude for 0, now that amplitude is for 1. Whatever the amplitude for 1, now it goes to the 2. That signal is started from plus 1. There is only one difference is there. That's it. Whatever the signal is starting from 0, now that signal will start from plus 1. So this is nothing but advanced shifting. This is called as a advanced shifting. Now next one, next operation. Next operation. Suppose if you have to write r of n, r of minus n plus 1. So how we can write? First you have to shift and then reverse. So first you have to write r of n plus 1, that already we have taken. So just we have to write r of minus n plus 1. So how we can write? So whatever the signal is starting from minus 1, now that will be changed from plus 1 having 0, for 0 having 1, minus 1 having 2, minus 2 having 3, minus 3 having 4, minus 4 having 5. So whatever the signal is there r of n plus 1, that just we have to reverse the signal. Okay. Next signal that we are going to draw, for example, if I want to draw r of minus n minus 1, we have n minus 1, so we just have to reverse that. So whatever the signal is starting from, now that signal will be start minus 1. So minus 1 having a 0, minus 2 having 1, minus 3 having 2, minus 4 having 3, minus 5 having 4. So basically the we have to reverse that n minus 1 signal. Next, if I write another one operation like if I take r of 2 into r of n. So what is the meaning of this? So basically you have to amplify the signal. So what is amplitude for 0? Obviously is 0 amplitude. For 1 having a 1 amplitude, now that amplitude will be 2. Whatever the amplitude for 2 is a 2, now that amplitude become 4, and whatever the amplitude for 3, so basically is a 3, but now you will get 6. So these are the different amplitude that we will get at each and every point. So basically is nothing but amplitude amplification. So I hope now we understand overall how to do the operations on a discrete time unit ramp functions. So if you have any doubt regarding this topic, then you can comment on my video and subscribe my YouTube channel and share this video so that it will help the other student also to understand the operations on a discrete time signal. So in the next lecture, we're going to see the next operations on the different signals. So